on a European vanilla call option, which was basically, the argument was that CT, the European vanilla call option, must be greater than or equal to the price of the underlying asset minus the discounted strike price back from expiry. So what I now want to do is to run through a similar argument for a European put option. So here again, the rabbit out of the hat thing is you consider a portfolio which is long one share and long one option, put option. So we hold both the share and the put option, and then at expiry, the value of that portfolio is the value of the share plus the value of the portfolio, the value of the put option. So that equals, of course, the share value plus the max of K minus ST and 0. That's the value of the put option. So that is equal to then, it's either ST plus K minus ST, which is just K, if ST is less than K, or less than equal to, and it is ST plus 0, which is just ST, if ST is greater than K. Okay? So depending on which part of the option you've got, that's what the answer is. So the thing that we can conclude therefore, though, is that ST plus PT has to be greater than or equal to K. Alright, why is that? Well, it's certainly equal to K here, if ST is less than K, and it's equal to ST, but ST is greater than K in this other case, so therefore it has to be greater than or equal to K in both scenarios. Okay, so that's certainly the first idea, that at expiry that's the case. So then the conjecture is that at time t, you have ST plus PT must be greater than or equal to K e to the minus R t minus t. So why is that? Well, it applies that rule of thumb that I said, wherever you see a K, you basically stick in a discount factor back from expiry. So ST and PT then become little s, t, s little t, s little p, so be greater or equal to K e to the minus R t minus t. So the discounted value of the strike price back from expiry. So again, we're going to prove by assuming there does not exist arbitrage, and assuming the opposite, ST plus PT is less than K e to the minus RT minus T. Okay, and assume the opposite, i.e. there exists a T such that that's the case, and then showing that this implies arbitrage. Okay? So we'll assume the opposite and then prove that that implies arbitrage, so it violates the no arbitrage condition. So suppose that is in fact the case. So let's suppose that we've got that. Then at that value of t, we start with nothing. Okay? And we've got to remember that you sell the expensive and you buy the cheap. So in this case, that's the expensive one because it's the biggest one. This is the cheapest one because it's the smaller of the two. Okay? So what does that mean? It means sell money. Okay, because that's what K e to the minus RT minus T is, i.e. borrow K e to the minus RT minus T. So I borrow that from the bank. And I use that to buy PT and ST. Okay, so I buy the share and I buy the put option. Okay? So PT plus ST costs me PT plus ST. I subtract the 2 and I get K e to the minus R T minus T minus PT minus ST. So that's the money that I've got left, and because of this assumption here, this false assumption, this thing should be greater than 0. Okay? Pull up 1. Pull up 1. Right? So by 1, that's got to be greater than or equal to 0. So what I do with that is, I take that and I invest in the bank. I put that money and put it in the bank. Now at expiry, at time t, capital T, the debt rises to, well, I initially borrowed K e to the minus R T minus T. I've got to multiply it by the debt, the interest, e to the RT minus T. That's the continuous time interest. The total debt rises by that amount. So the debt is now K. What's the value of my portfolio that I'm holding? Well, I'm holding PT plus ST. Okay. Well, that equals PT plus ST. And if I subtract that, what do I get? I get okay, so the value that I've got, sorry, should do it the other way around. Okay, but it's PT plus ST minus K. So that's my net assets plus the cash in the bank. All that 2. Okay. So what is my net profit then? Or what net position? Okay. Well, my net position is PT plus ST minus K, but we know from here, okay, from this thing here, which is correct, from equation 0, we have PT plus ST minus K is greater than 0, and in addition, I've got the cash in the bank, even without that. But the point is that that is certainly greater than 0, which gives me a guaranteed profit. Okay? So the point was I started with nothing and I've gone to guaranteed profit of PT plus ST minus K. Okay? Plus the cash in the bank. So that means that there implies that there exists an arbitrage which violates the assumption so it implies something's wrong, and the only thing that can be wrong here is 1. So that implies that 1 is incorrect, so the opposite of 1 must be true, so that ST plus PT must be greater than or equal to K, e to minus RT minus T. So the opposite of 1 is true. Okay? So, that is essentially the argument of prove the lower bound on the put option. So you start off with a bit of a rabbit out of a hat here, but it gives you the absolutely guaranteed inequality that you have at expiry. Then you assume the discounting factor here, put that into the conjecture for t less than t, or t up to t. You then assume that the opposite is true with a no arbitrage assumption, and then you go through and you sell the most expensive side, you buy the cheaper side, and so you borrow the money, buy this, you get some leftover money that you put in the bank anyway, but even despite that, when you run through, as you go to expiry, you find that if you hold the put and the share, you can actually sell, you can basically, after you've liquidated those assets, you can pay off your debt, and you've still got a positive amount of money left over, given the values, this is guaranteed, this is correct at time t. And so, it's less than or equal to 0, plus the cash in the bank, means that you overall have a guaranteed profit. So you could end up in a scenario where you don't get anything here, but with the extra cash in the bank too, that will tip you over the balance, and it means that you've got a guaranteed profit. That means that an arbitrage exists which violates the no arbitrage assumption. Something must be wrong in the argument. The only thing that is wrong, that can be wrong, is this assumption here, because that's certainly true. So in a no arbitrage environment, the opposite has to hold. Okay. Any questions on that? Right. Let's have a look at some upper bounds. So an upper bound on a euro call. Okay, the conjecture is that the euro call is always cheaper than the asset, or less than or equal to the value of the asset. Okay. Why? Well, again, it's proved by contradiction. So assume arbitrage. Assume there does not exist arbitrage. Okay, and assume opposite, i.e., CT is greater than ST for some t less than t. Okay. So I'm going to start with nothing, okay, at t. And so what am I going to do? Well, in this case, this is the expensive, and this is the cheap. Okay? So, if you sell expensive, buy cheap, so you sell, i.e. you write one euro call. Okay, that means that you get in your cash in income is CT. You buy the underlying share. That costs you ST. CT minus ST, according to this, is greater than 0. This money invest in the bank. Okay? It's greater than 0 by this assumption here. So then we're at T, at expiry. What is my liability? Well, let's look at my assets. Sorry, my assets. Well, my asset is I've bought the underlying share, so I've got ST in my back pocket, or I can sell it for, at that point, I can sell it for the value of the share at expiry. My liability, what is my liability? Well, I've written a call option, so my liability is the payoff of the call option at expiry. So it's max of ST minus K and 0. And if I subtract that all off to find out what my liability is, it's going to be, I'll continue over here. So the liability is, it's going to be ST minus K, which is just K, and that's the case if ST is greater than or equal to K. And it's ST minus 0, which is just ST, if ST is less than K. Okay? ST greater than K. And of course these are both positive. Okay? The share price has to be positive, and the asset and the strike price by definition has to be positive. And I've also got this amount of money in the bank. Okay, so I had that amount left over and I invested that in the bank. So clearly overall I have something that's greater than 0. So therefore we violate, so I've gone from 0 to something greater than 0, which implies an arbitrage. I violated the arbitrage, or it contradicts the no arbitrage assumption. Something must be wrong. And if we make the assumption of that there's no arbitrage, the only thing that can be wrong is this thing. So the only thing that can be wrong is 1. So the opposite of 1 must be true, which implies that CT must be less than or equal to ST. So the European vanilla call option has got to be cheaper always than the actual underlying asset price. If you see any time that it's not, you can make easy free money. Right, what other ones have we got here? Bound and option prices. Yeah, there's an equivalent European one. On the Euro put, sorry. And that one comes out as PT, or PT, is less than or equal to K e to the minus RT minus T. And you can go through and read for yourself and prove that to yourself. By contradiction, you can prove a similar argument there. So that's in the notes. The argument is here. You can play with that yourself. Right. One of the really important things that we come across now is put-call parity. So all that we've done so far is to relate the individual option prices to the underlying asset and the and what we got? We've got PT less than K T. That's the upper bound on that one. What was the lower bound? So those are the bounds that we've got so far. We've got upper bounds and lower bounds on the European call and the European put options. Okay. What the put call parity does is it relates the values of C to P. Okay. And this actually one turns out to be, because it's called parity, this has actually got an equal sign in it. Okay, so this actually definitely relates the European call value to the European put value to the underlying share price and the strike price by inequality. Doesn't allow us to determine individually what CT or PT is, but if we know one, this called parity can tell us the other. So this argument runs in a similar way. I'm going to consider two scenarios, A and B. I'm going to hold a portfolio which is a call option plus an amount of money ke to the minus RT minus T. That's part A of the portfolio. Part B, a separate portfolio, is a put option and the underlying asset. Okay? Now, at time T, at expiry, what have we got? What is the value of this portfolio and what's the value of that portfolio? Well, the value of that is it's CT plus K, okay, because the T equals capital T, so this just becomes CT plus K, which is then the maximum value of ST minus K, 0, and equal to K. So that equals ST minus K plus K, which is ST, or ST greater than or equal to K, and it equals just K, or naught plus K, which is K, for ST less than K. So that's the value of portfolio A. If I now look at the value of portfolio B, at expiry it's PT plus ST. What's the value of PT at expiry? It's the maximum value of K minus ST and 0. The value of ST is just ST. If I see what that equals, well, for ST greater than K, this is 0 plus ST. So it's ST for ST greater than or equal to K. And for ST less than K, it's K minus ST plus ST, which is K for ST less than K. And now, lo and behold, those two portfolios have the same value at expiry, whatever the outcome. Okay? So those two portfolios theoretically are the same at expiry. So the conjecture is, are they going to be similar, identical at T less than capital T? So, conjecture. We've got the conjecture that